Hello and welcome to Unit 2, Lesson 4, More Multiplication Properties of Exponents. In this lesson, we look at two properties, raising a power to a power and raising a product to a power. Our vocabulary reminder is just our basic exponential vocabulary. So in green there, we have a base, which is the number being multiplied. And in red, we have an exponent, which is how many times the value is multiplied. That exponent shows the repeated multiplication. And then altogether, it's called a power. So 7 to the third power. So we remember those as we go through today's lesson. Our first lesson, or our first property, is a power to a power. So let's go ahead and scroll down here. Okay, so our power to a power property of exponents. This property says that to raise a power to another power, we have to multiply the exponents. So in math terms, we see that a to the mn equals a, the base stays the same, and we multiply the exponents, m times n. So we get amn. So let's take a look and practice a few together. So in our first example here, we have 2 to the m. So our base is 2m, and we're going to do that to the fifth exponent, or 5 times. So what this looks like if we were to write it out long ways is 2 to the m times 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 2 to the m. And so now we have our bases, and we know that when we have the same base, we can add our exponents. So we would have 2 to the m plus m plus m plus m plus m, which equals 2 to the 5m, because there are 5 m's here. So our property simplifies that for us up here and says that if we have a power to a power, we can just multiply these two exponents together. So instead of going through all of the process of writing each out, if we have a power to a power, we can multiply them together right away to get 2 to the 5 times m. Typically, we write the number first and the variable second, so that's why I switched that to 5m and not m to the fifth. So let's use our property in this example here. We have d times d to the negative third to the negative second. So in this example, we have the property, we have a d alone, so we're going to just go ahead and write that by itself. And I'm going to separate this out so it's a little clearer. This negative 2 exponent is only going to what is in parentheses. So we have d to the negative third to the negative second. And so our single d stays the same. And then our property says if I have a power to a power, I'm going to multiply those exponents. So I can rewrite this as d to the negative third times negative 2. So I get d times, and when I multiply those together, negative 3 times negative 2 is a positive 6. Now I'm not quite done yet because I learned another property before that says if I have the same base, I can add my exponents. So I can write this, and remember if we just see d alone, that really means it has an exponent of 1 times d to the 6th. So this can be written as d to the 1 plus 6 or d to the 7th power. So take a minute and review this property, pause the video, and come back when you're ready for the next property. Our next property is similar, but just a little different. This is the product to a power property of exponents. So let's remember that product means two numbers multiplied together. So this property says to raise a product to a power, or numbers multiplied together to a power, we have to raise each factor to the exponent and then simplify. So looking at the math here, we have two numbers multiplied together, a and b, to the m power. So that m goes to each factor. So that becomes a to the m and b to the m. So let's take a look at a few examples together. In this first example, we have 3a to the negative 6 power to the negative 4th. Now, this means that this whole thing goes to the negative 4th power. And in this term, we have a 3 and we have an a to the negative 6. So this can be rewritten as 3 to the negative 4, because the power is outside of the parentheses. The negative 4 goes to 3, and the negative 4 goes to a to the 6th. So we're going to break up those two factors and rewrite this, a to the negative 6th to the negative 4th. And now we can simplify by writing these with our other rules. So if I have 3 to the negative 4th power, we remember that anything to the negative power goes to the denominator. So we have 3 to the 4th, 1 over 3 to the 4th, times, and then we just learned above, if I have a power to a power, I'm going to multiply those. So I get a to the negative 6th times negative 4th. And so I have 1 over 3 to the 4th times a to the positive 24th. And when I multiply these two together to simplify one last time, the a to the 24th, since the 24 is a positive exponent, it stays in that numerator, and our 3 to the 4th is in the denominator. So remembering we started this problem off because we had two factors that were multiplied together and raised to the same power. So we had to start by splitting them up and raising them each individually to that power. So let's take a look at another example. We have r squared s to the 5th power. So the parentheses tell us that both factors go to the 5th power. So we're going to rewrite this as r squared to the 5th power times s to the 5th power. And we remember that a power to a power means that I multiply, so I get r squared times 5, so 2 times 5 times s to the 5th power. And we can rewrite this. 2 times 5 is 10, so we can rewrite r to the 10th times s to the 5th. And we can write it even a little more simply here as r10 s to the 5th power. So take a minute and look at each of those examples. Make sure you understand the power to the power, and we'll do a few more examples when you are ready combining all of our properties. So by this section, we have learned many different properties of exponents, and we have to put them all together and utilize all of them in order to simplify an expression. So let's take a look at a few examples. The first example says h to the negative second times h to the fourth times h to the negative third. The one thing we should notice is that we have the same base. So when we have the same base, we remember that that means that we can add all of our exponents together. So if we have h, we can say this is negative 2 plus 4 plus a negative 3. Because they are the same base, we can start, and they're all multiplied together, we can start by adding our exponents. So we end up with negative 2 plus 4 is positive 2, plus a negative 3 is negative 1. So the base stays the same, and our exponent becomes negative 1. Now we also know that we can't keep a negative exponent. We like those exponents to be positive, and we know that if we have a negative exponent, that means that we have to do the reciprocal. So we end up with h is currently in the numerator. It goes h to the first power goes in the denominator, and h to the first power just means h, so we can simplify this expression all the way down to 1 divided by h. Let's take a look at one more example. This one is a little more entailed. So let's start by breaking it up. When we look at this example, we see two different sets of parentheses, and so we're going to divide that kind of down the middle. And so the first set is b to the 6th to the 3rd times, and the second set is 8ab to the negative 4th, and all of that is squared, or to the second power. So in this first part, b to the 6th to the 3rd, we have a power to a power, so we know we can do multiplication of those exponents. I'm going to go ahead and go all the way down here and finish that side off. So we have b to the 6 times 3, or b to the 18th. Now over here, we have a power outside, and we have 3 factors. We have a whole number, we have an a, and we have a b. So this side gets rewritten as 8 squared times a squared times b to the negative 4 and squared. And we can rewrite this as 8 squared times a squared times, and then b is a power to a power, so we have b to the negative 8th. And now we have to look for common bases, and we do have a common base here, so we can rewrite this as 8 squared times a squared. And if we have the same base, we can add those exponents. So we have b to the 18 plus a negative 8. And we're going to do one last simplification. So we have 8 squared is 64. A squared, we can't simplify any further. And b to the 18 plus plus negative 8 is b to the 10th. So we've learned two new properties, power to a power and product to a power, and then we practice putting it all together.